Hello, my name is Aldo Salazar, and today I'll be talking about water contamination in Puerto Rico and the use of artificial wetlands and bioremediation as a proposed solution to this problem. Puerto Rico is among the Caribbean islands with the most available water resources for a variety of uses. Unfortunately, over the past years, the island has followed a trend shown by most Latin American countries. This meant they shifted from an agricultural-based economy to big industries in response to the rapid urban growth and migration to the metropolis. This, in consequence, had a negative impact in diverse resources and ecological systems that have been disrupted by the accumulation of contaminants such as heavy metals, trash, chemical waste, and hydrocarbons. Therefore, the arising water contamination problem will have noxious consequences to the inhabitants of the island. The purpose of this project is to educate people on artificial wetlands and bioremediation to create long-term, self-sustaining artificial water plants. This aims to treat water independently from government facilities and ensure viable options for communities at an affordable cost. When we take into account that over 700 million people worldwide are deprived from water, we must appreciate and preserve the karst region in Puerto Rico. As we can observe in this figure, the Puerto Rican karst is located in the northern region of the island. This region is particularly important as it contains one of the most important water resources available to the island. Among the practices that take the most amount of resources are industrial use and commercial and mining withdrawals. Although household is not the most prominent one, it is indeed the most effective one. The main problem associated with both commercial and industrial use is their water disposal. While practices such as leakages and/or spills have greatly compromised ecosystems, like in 2010, when British Petroleum pumped over 20 million gallons into the Gulf of Mexico for 87 days. When we look at some numbers, there are approximately 40 pharmaceutical companies that produce drugs like Advil in Barceloneta that have private wells from these water sources. All over the island, 772 million gallons per day are processed to give water to 3.99 million people to supplement clean water. This means that the available water resources are scarce. When we take into account that the minimum 40 million gallons per day are destined to those 40 companies, we are talking that we are depriving Puerto Ricans from over a third of its underground resources to benefit private companies. As we can see, finding alternative methods to clean and purify our water resources will enhance our life conditions and do not entirely depend upon water treatment plants to do so. Continuing on these facts, pharmaceutical companies have been associated to the contamination of over 41% of Puerto Rican wells, which roughly translate to 11.6 million gallons per day. This creates a serious problem, since the water quality is one of the best and proper waste management has been negligently conducted. This, of course, puts neighboring communities at risk depending on the kind of waste and its concentration with a long-term ecological disruptions. In 2005, approximately 150 million gallons per day were demanded for 3.9 million people from underground, surface, and desalinated water sources, from which, as stated before, 20% comes exclusively from underwater sources. This proposes a problem where the most viable water resource for household activities is neglected and rather being used for commercial purposes instead of prioritizing citizens. According to studies in 1995, a common Puerto Rican household uses 92 gallons per day. If we compare this number of million of gallons per day designated to agricultural use, we note that we have 59.2 million gallons per day for both irrigation and livestock versus 69.5 million gallons per day for household use. This points out another problem, since the amount of clean water resources available are not being properly used. If the amount of water used to generate food is somewhat similar to household use, then we must ensure that we use it properly. Although both of these values do not compare to industrial use, this makes us wonder if we are really using water efficiently and we just want to blame the problem to someone else. But how do these companies really affect us? Usually, companies establish where resources are available and they're beneficial to their finances. By establishing near the coast, pharmaceutical companies ensure easy access to underground water, reducing immensely transportation and logistical costs, therefore increasing their profits at the expense of others. This might be beneficial to the economy, but ecological disasters are not exempt from these practices. For instance, a leak or spillage from a waste conduit can permeate to the aquifers, diluting its contaminants to other water bodies, as we can observe in this figure. Now, What do we know about these industries and how can it affect us? Here, I'll mention some specific threats. The biggest hazard issue associated with industrial use are toxic metals. These wastes affect primarily urban and rural communities, not to mention the ecological impact, causing long-term issues associated with a variety of health problems. Some of the most common and toxic heavy metals are lead, mercury, arsenic, cadmium, and copper, which lead to the contamination of fields, soil, fruit, and vegetable sources. This makes it relatively easy to propagate and harm the population, causing minor effects like nausea, vomiting, sweating, headaches, and some problems associated with motor and language skills. On the other hand, when the toxic builds up in the body, it can lead to fatigue, reduced ability to assimilate nutrients, depression, brain damage, memory and learning problems, and it can also lead into organ failure like renal or liver. The overall problem lies that most of these hazardous metals cannot be properly treated by water plants. This means that vestigious traces can be found even after the treatment, as the following figures will expose. Here, we can observe the contamination of these water bodies located in Mameyes, Rio Piedras, and La Plata. It is important to note that these metals have adverse consequences in our health. As we can observe in these graphs, the concentration of these specific heavy metals in parts per billion in these rivers show the imminent threat to human health. For example, arsenic poisoning affects metabolic routes, which can cause nausea, abdominal pain, and heart arrest. Following the same line, barium can cause respiratory and gastrointestinal failure, kidney damage, and even paralysis. Some severe cases of multiple sclerosis have been linked to barium poisoning, although it has not been confirmed yet. Cadmium, on the other hand, is a carcinogenic metal which can cause chills, fever, and muscle ache. This metal, in long exposure, can cause pulmonary problems and kidney failure that can cause death if it's not treated properly. Finally, manganese alters the iron absorption, which leads to fatigue due to the hemoglobin reduced activity as well as similar effects as shown in Parkinson's disease. As we can observe, these metals cannot be taken lightly. The high accumulation of these metals has deadly consequences which, in low-income communities, may not be easily treated due to the cost of healthcare. In this table, we see the values expressed in percentages of the total contaminants present in the water bodies. We can note that manganese is the most common heavy metal present in this study, followed by cadmium and arsenic by a substantial difference. This study shows how contaminants not always follow the logic of higher concentrations near the source and a degradation as it gets further away. These water bodies are connected to wells that serve as water source to the metropolitan area of Puerto Rico, which exemplifies the magnitude and the impact that these metals can have in our society. Therefore, the need to create alternative ways to cleanse the water and not solely depend on water government facilities arise once more. So, what is bioremediation? Bioremediation is one of the cheapest methods to conduct remediation through the use of microorganisms to degrade hazardous molecules into more usable ones. The fundamental characteristic of remediation involves the utilization of the metabolism of these organisms to conduct chemical reactions in aims to re-establish the damaged ecosystem. The benefit of this process is 1. That it is enhanced by the addition of key nutrients such as phosphorus and nitrogen to accelerate their metabolism, and 2. That these bacteria are already present in the affected environment. Therefore, no substantial economical investment is needed to accelerate the process other than the addition of the aforementioned nutrients. So, how does this work? As we can observe here in the workflow, you can turn complex hydrocarbons into less complex hazardous molecules. This, along with the synergetic effect of some organisms such as the species of the Rhizopin genera, enhance the process with mutualistic relationships with plants. Therefore, by adding limited nutrients like phosphorus and nitrogen, we can increase the rate at which these bacteria will conduct bioremediation, taking the hydrocarbons into simpler molecules. In this phylogenetic tree, we can observe the diversity within Vega Baja's hydrogas station adjacent water bodies that have been studied for its concentration of heavy metals. The surprising factor relies upon the microbial diversity present at the given site. Bacterial families such as alpha, beta, and gamma proteobacteria encompass the largest amount of known organisms capable of bioremediation. Now, moving to constructed wetlands. In order to enhance the bioremediation, constructing wetlands will aid the process. Wetlands are transitional areas between water and land. These environments can range from swamps to wet meadows. Some of the benefits that wetlands give are water quality improvement, cycling of nutrients, active recreation, education and research, and landscape enhancement. Due to the saturation of water in the substrate, the slow and shallow water depths allow sediments to settle as the water passes through the wetland. This provides extended periods of exposure between the water and the numerous surface of the constructed wetland. Therefore, these wetlands support the growth of vascular plants adapted to saturated conditions, which creates microenvironments where microbial communities can flourish. In conclusion, constructed wetlands use the physiological properties of plants to create proper environments for microbial mats in order to purify the water that passes through the system. As we can observe here, this wetland was constructed by the University of Murcia and consists of a properly designed basin containing water, substrate, and the vascular plants. The substrates used to construct these wetlands include soil, gravel, rock, and inorganic materials like compost. These are important as they support the living organisms present in this artificial ecosystem. They also regulate the permeability, which affects the water flow and the chemical and biological transformation of molecules. Most of these organisms are part of the Proteobacteria, where organisms like Pseudomonas, Acinetobacter, Rhizobium, and Azotobacter species are all ubiquitous oil degraders associated to the rhizosphere of dense, fibrous root system plants like cattails, bulrush, rushes, and sedges. This in consequence provides storage for contaminants that act as carbon source for both plants and microorganisms. Here, I will present some of the most common points that prevent the construction of wetlands as well as some of its advantages. First of all, the main concern regarding wetlands is the cost of construction. Since they require a large amount of land, more than conventional treatment plants, people are reluctant to build them. As a matter of fact, the amount of land that is required for the system is approximately 300 square feet to produce approximately 750 gallons per day. If we take into account that the average cost of a 3,200 square feet terrain can hold 10 systems, we would produce 1 gallon per day at the cost of $5.89 from a terrain of an original cost of $50,000. Other point that is used against them is the high variations that wetlands undergo. One can observe variations on efficiency levels with seasonal changes as the microbial communities are affected by weather. Although some studies reflect that the average efficiency does not seem to be affected, treatment cannot be relied upon if a constant quality must be met. Therefore, Puerto Rico, being a tropical island, will not experience these fluctuations in its efficiency as the climate does not change drastically as in other parts of the United States. Finally, one of the main contradictions that are used against wetlands is that biological components are susceptible to toxic chemicals like ammonia. Although this is partially true, the organisms employed in the construction of wetlands have been particularly chosen by their characteristics of withstanding these conditions. Also, the use of zinc can help to clean the system from metals and phosphorus that might inhibit the metabolism of some of its participants. In conclusion, we can observe how the use of the proposed plants and microorganisms will not have a negative effect on the Puerto Rican ecology as all the components are native to the island. The bioaccumulation can be treated by the chemical reactions done by the organism's metabolism. Nutrient recycling is one of the most important characteristics wetlands provide as it allows microbial synergism with the plants where they benefit from each other's waste. Also, the capability of cleansing the water in the scenario of bioaccumulation is a potential threat help improve the life expectancy of the construction. Finally, the cost of construction has been proved not to be an issue. By a cost of construction that is under $6 per gallon, one can assume that the initial investment will be paid off within years. Therefore, I believe that the construction of an artificial wetland will help the communities that live near the contaminated waters near the metropolitan area of San Juan. By community effort, the construction cost can be divided in order to afford a cheap alternative solution to clean water. And after all, water is an essential element and we need it for everyday life. Why not think about our future and start thinking about a solution and have a better future for our kids and future generations? Thank you.